try to read it, and then I forget. Then I forget about it. So if you really want to contact me, like it's been 2 hours and it's like bugging you and you want to find out something, you can text me again or email me again. Like it's fine. Like you're not gonna bother me by trying to contact me a lot. And like some teachers are like, oh, let 2 days go by, or if it's the weekend, you got to let the whole weekend go by, and I'll get back to you on Tuesday. You can just try to contact me again. It's okay, because I'm kind of like that. I mean, I used to be like that. When I want to know something, like I just want to know, I want an answer. Like I don't want to wait. Usually it's like test related, right? You want to know like what you missed on the test or why you didn't, or maybe I forgot to post your grade or something, right? And so you want to know right away. And I'm fine with that because I'm kind of like that. I'm gonna let you read all through this stuff. That's our for you guys online. If you could do me a favor and just type your name in the chat box, just so I know you're here. The book, it's free. To be honest, any biology book will work. But I'm using OpenStax, so you just click on that link, and it should open up to the book. I'm gonna try it, see if it actually works. And we're going to start off with chapter 2, probably. So we're going to be skipping chapter 1, and we're going to go to chapter 2. And I follow the order. It's just that the book is going to have some things that I might not talk about. But in general, like if you just go to each of these things, like this is where I'm going to start today. I'm going to talk about atoms, like what an atom is, what what's an ion, ionic bond. That's this 2.1 is probably as far as I'm going to get today, and I'm fine with that. I'm not trying to bombard you, especially today. So that's probably all I'm going to do is 2.1. But anyway, there's the book, right? It's a good book. So. How does the book look? Like the actual book? Well, that's a good question. I don't know. They make like if you want to like read like an actual book. Some people want to like hold the book, like they're not good with it. Is that what you mean?
No, like a book for the game.
Yeah, this is it. It's it just looks like this. You can download the whole thing if you want to. It's a PDF. So, like right here, you could just download it to your phone. I've never tried it. I'm sure it works. But you can download the whole book itself. Or you could just keep going back and look at the whatever chapter you want. If you want to order and actually pay money for it, you can do that. You can order one from them if you want to like touch a real book. But if you have a biology book from anything, if you have a biology book from like high school or whatever, they're all the same. They're all really, really close. So it doesn't matter to me. So there's other books on this OpenStax too. There's like psychology and economics and sociology and anatomy. There's all sorts of books they have. All right. let me come back to that. Let's go to this. How am I going to grade you? We have exams, 3 quizzes, and then this thing called Conover, which you may have already done in another class, and if you did, you're lucky. If you didn't, well, you know what? If you did it, you're still kind of lucky because it's 20% of your grade, and it's not hard to get an A on that at all. So that takes the pressure off a little bit. You know, consider it like homework, right? So 3 quizzes, 3 exams, and then homework. So this thing that is Conover, this says Conover, it has nothing to do with biology. And it's not something that I necessarily am assigning to you as like the biology teacher. It's being assigned by the college. Certain subjects get this assigned. So this particular class happens to be one of those. You might be taking like English or something, and you'll have the same thing. This thing called Conover. And if you do, you only have to do it once. Right? And if you already did it, I'm going to give you credit for it. So let me scroll up a little bit and talk about it. So there's this idea that you're supposed to have like soft skills. So it's one thing to like have a degree and take a class, but when schools send like students out to get a job, I'm not saying you guys, I'm saying some people, many people are doing things like their resume is filled with like spelling mistakes, or they're not making eye contact, or they have their phone out in an interview and they'll try to look at a text like at an interview, and it's like, just stay cool for like an hour, right? This is like a job that will give you money, and you know, so there's like certain things you should like do and not do. And so, you know, a college is supposed to be tasked with like 2 things. Like, it's one thing to give you a degree, but we're also supposed to set you up. I mean, really, you're probably here for a job, right? This class is not necessarily the class you want to take, but you got to take that so you can take another class, and eventually somewhere it's going to end with a job that's a bigger paycheck than what you're getting at Subway, the dollar store, right? And you want to trade in that Nissan Versa, and you want to get the Altima, and like the nicer Altima, right? And so all of that, this is kind of like part of that, right? So it's not just the degree. People aren't looking for only the degree. They're looking for the degree, and then you also have to be someone that knows how to work with people, you know, and I don't know. It doesn't have to do with biology. Just do it. They're useful things. So we have that, and all you do is you're going to click on this site, and it's probably not ready today, but it will be ready in a few days. And it's just going to be the email that you use for Canvas. So whatever email you get, like I sent you an announcement, whatever email that went to, that's your username. And then your password is going to be Conover. You don't have to start this stuff today, but don't wait till the last minute. People that wait till like the last week, they end up not doing it. It's like too much work for them to do like in 2 days, right? So just do like 1 a week or something like that, right?
Mr. House.
Yeah.
Wait, what is this again?
This is what you had me for this. You had this already, right?
I'm not sure. Remind me. I don't remember.
This is that thing Conover, and it's a lot of stuff that is not biology related. It's more.
Is it lab stuff?
No,
Oh, I was getting ready to say because I know lab you had us like go on like I think my lab and do a whole bunch of exercises and stuff. So wait,
yeah,
I don't remember us doing this at all last
no,
semester.
lab will be different, and that's not going to cost you anything this time either. So,
Okay,
no, this is a little bit different.
because I know this is that this. I know in our lecture class like last semester, I don't remember us doing anything really online.
This is called a quality enhancement program. Every college has it, and every college does something different for their quality enhancement program. This is what we do for it, and I've got it explained somewhere in here. But
Is that in our announcements?
this is like a college-wide thing.
Oh, okay.
So you might get stuck in another class in the future that you're going to have this same thing, and hopefully you'll have it done, and your teacher will be like, "Yeah, you're fine." Right.
Okay.
I decided to assign it give you some points for it because I don't know because you'll probably get like 100 or a 95 on it.
Oh, you think?
That makes it easier for your tests. You don't have to do as well on your exams and quizzes.
Yeah.
So I'll go over that again, like in another class. Like I'll show you. Oh yeah. So attendance. So Mondays I will be here every Monday and every Wednesday. On Mondays, you have your choice. You want to like some people aren't here right now, but Mondays will usually be like this. You have your choice. You can come to class and sit in the desk, and I'll be here, or you can join on this same link that I sent you guys on the announcement. So that's Monday, but Wednesdays we take our, with exception of today, Wednesdays we take our quiz or exam. You have to be here for that. That's on paper, and you have to take it on paper. So there's no online exams. There's no option to take online exams. I don't have an online exam. It might look like it well, actually, you shouldn't be able to get to it anywhere. But if you happen to see it somewhere, you won't be able to take it. It's not. So all the exams, quizzes, exams, that's in class. It's on paper. It's every Wednesday. And since you're here Wednesday, what's that?
Will the test be multiple choice?
No.
Now look, we had this conversation last semester. Now Mr. Collins gonna do
I
it.
know. And I just, you know what? It didn't work last semester.
It worked for me. I passed with a D. So hey.
That's not working.
We want to have a separate conversation about this after class.
But you guys do. They're not multiple choice. And we had a thing like last semester about this, and you guys just do better. Like the class does better when it's like a short answer. And I know that's not intuitive, right? You're not thinking that in your head. You're like, no, I need multiple choice because I need like a reminder, right? You don't want to learn the word. It's the word that starts with a W, right? And it's like a safety net. You feel like you can handle it better when it's multiple choice, but you don't. I never did. You guys don't. You think you do, but you don't. And it makes you study less and prepare less because you think you've got it. And then you don't get it. And you're like, man, I just didn't. Because all the answers are going to start with a W. It's not a bolded word with the definition. And then when you take the test, there's the bolded word and you pick the definition. It's hardly ever like that. Right? So just trust me. You'll do better with these tests that I give. I've played around with it. Now I'm not doing it I'm not giving you like written short answer type of test. I'm not doing it to make it harder or to make your grades go down. I'm doing it the other way around, right? So you could say, well, why don't I just make the test a lot easier? I'm not doing that. I mean, you have to learn something. You're in the class. Let's learn. But I'll say this: it's a lot easier than if I were to use like a test bank. Right? So the grades go up when I give this type of test. When I switch back to multiple choice, grades go down. I've been playing with it for years. So yeah, so Monday, it's up to you. If you wanna starting Monday, you'll need your cameras on, because y'all, just like me, I whenever I'm in a meeting, I put my camera off, my microphone off, and I go do something else, which is fully what I would expect you to do online. That's why you got to have your cameras on, because you're not gonna, many of you are you're not gonna watch the recording, and you say you're gonna watch the recording and you're not, and that's exactly what I would do too. So I'm not trying to judge you. So nothing until next Wednesday. Next Wednesday is our first quiz, right? And you'll know what I'm gonna ask. I tell you roughly, you have to know this, you have to know this. I'm gonna ask about this. It shouldn't be a big surprise. It's just that you have to spend some time studying. And a lot of you are going to take other biology classes. So the more you know from this class, the easier it's going to be if you have to take micro or anatomy and physiology. It's just because all this stuff, all these ideas presented in this class are going to be used, are going to come up again in anatomy, microbiology, whatever, including the chemistry, right? You're like, why do I have chemistry like this week and next week? This is biology, right? Biology is supposed to be about things that are living, but chemistry is the background of biology. So, you can't have biology without chemistry. You can't have chemistry without physics. You can't have physics without math. So, So we're going to talk about chemistry today. Not heavy chemistry, not like high school chemistry. I don't know if you remember, if you ever took chemistry and you had to do all those balancing equations, and we're not doing that. We're not balancing anything. I don't know how to balance. I still don't know how. I don't know what they're doing. We're not going to put numbers in it. I'm just getting you from point A to point B. I just want you to know some basic chemistry to understand biology. So we're not messing with everything. We're not going to mess with a whole bunch of atoms. We're only going to talk about 4. So, but I am building you into something. So an atom, if you put atoms together, you get molecules. And then when you put molecules together, you get a cell. And then when you put cells together, you get what's called a tissue. And you put tissues together, you start to get organs. Put organs together, you get a system, like respiratory system, cardiovascular system. You put all the systems together, you get a human, right? So that's kind of where a lot of you are eventually going to go to. So we're going to go all the way to tissues. So we're going to start with the atom, and we're going to build up, and we're going to get to tissues by the end of the semester. It moves fast. So we finished in the middle of March. So we go a little bit longer, like taking it in the summer. Okay. So that's our schedule. Every Wednesday, plan to be on campus. I'm going to let you read all this stuff. Yeah. Blah, blah. I'm recording, so just a heads up. Okay, I just see a big mistake I put here. No, that's true. This is true. If you get COVID, obviously stay home, and we'll work something out. But you're gonna have to still take the test on campus. It's yeah. I'm not gonna put it online. So but you know, if you have to miss like a Wednesday because you have a positive COVID test that you sent into the college, then yeah, I'll record that class too. So, and like today, for example, I'm gonna drop this recording. I'll show you where I'm gonna put it.
I was just fixing to ask you about that because at the moment I'm home quarantined because my daughter has it. But when I woke up this morning, I have symptoms and I'm going to get tested as soon as this is over. And there's a possibility I may have to miss next Wednesday. So I was going to ask about that.
You know, and if that happens, I mean, what, you know, yeah, if it happens, it happens. It's gonna happen with a couple people. You know, some of us are gonna get it and have to stay home and have to reschedule, and we'll just figure it out as it comes, right? If you're, you know, maybe you'll start feeling stuff. Well, you said you're feeling like even today, right? So you might be out through next week. We'll just deal with it. We'll just deal with it, and we'll find a time. We'll find a time to come in and take it, maybe like around another class you have or something. We'll just figure it out like case by case.
Okay.
Yeah, so it's going to happen. You guys want to hear something messed up? My son was getting married just this last Sunday, and we had the place rented. We actually rented like a place over in Eden Isles, like one of those houses, like one of those big houses, and we were going to have it underneath. It was cold as shit that day anyway, so glad. But Saturday night, the bride got COVID, you know, so we had to cancel like the whole wedding. So I don't know why I told you. Oh, because, you know, shit happens, you know, and it sucked. We canceled everything, and we never had it. And they're probably going to go to City Hall and just do it this weekend and just finish it, because they're like, forget it, we're not rescheduling. So, you know, I mean, who knows? Like, I don't know. So, I don't even know why I told you guys. Just saying, you just take it day by day. Modules. Let me click on modules. Right, so the syllabus, you click on home, you get to the syllabus. Modules will have notes, and I've got some notes up there right now. So when you click on modules, I'll usually set it up by the quiz, right? So like right now, I've got these 2 videos that is talking about stuff I'm going to put on the first quiz. I'll add underneath it, you're going to see today's lecture. I'm going to post that on there too. And then after quiz 1 is done next week, I'm going to roll everything over into exam 1. So it'll say exam 1 material. And then you just study that stuff, right? And then when exam 1's done, then it'll be quiz 2 material. And the old stuff's going to drop off, right? So I don't want you to study stuff that you, like the wrong stuff by mistake, right? So I just organize it like this, right? I'm going to keep adding some stuff to this, but they're not necessarily like this video I made and this video, they're short. They're like 7 minutes or something like that. Like maybe one's 12 minutes, one's 7 minutes, right? And some of it's redundant. Like today's lecture is covered here also, right? So it's not like you have 10 videos or 10 different things you have to look at. Some of it's done twice. So, you know, I'm going to add to this stuff here, and it's going to look like it's long, but it's really not. I just have it in 2 different ways. Yeah.
The screen looks very far away.
It is. Still? Well, I'm going to be writing on the board in a minute, so you'll be able to see things better.
Okay, as long as you're writing on the board.
Yeah, and all I did was I just went to modules. And then grades. Oh, yeah, okay, so you won't be able to, if you click on any of these, it's just going to take you to that. Right, so there's nothing to take. I just put it in here to give you the days. And it's not due by. There's just no good way to do it in Canvas. Right? This is just saying that this is the time, and I'd really like to start class at 9 o'clock. I was going to talk with you guys about that. I'm already getting some approval. Yeah, so I'll probably check, because it's like, there's like a difference between 8:30 and 9 o'clock as far as people that got to like drop kids off for school. And I don't know, there's just something about it. Like 8:30 is like super hard to make. 9's a lot more manageable. And we're hybrid. We're a hybrid class, so I've got some room to do that, right? Because I've got videos posted online and stuff. So, yeah, so I thought about doing that. But these are the days, right? And this is essentially every Wednesday. That's all that is, right? But the grades are all as I put the grades in here, it'll give you an average. Right, so as I put stuff in, you'll have your average at the bottom, right? So you should have never. When I try to grade stuff on Wednesday, but more often it's Thursday morning before I get to it. Like a quiz, I'll try to do it on Wednesday and put it up. If it's an exam, it might take me until Thursday morning, but I'll have it up. Yeah, and then you could just see your grade, your average as you go along, right? And then you can put numbers in yourself. Yeah.
Just curious. So come Monday, do you want us to come be in here for 9 or 8:30?
I know it wasn't clear, huh?
Yeah, I just want to make sure I'm here at the right time.
Let's do 9 o'clock.
Perfect.
Are you guys okay with 9 o'clock?
Yeah.
You said 9 o'clock?
Yeah, are you guys okay with 9 o'clock?
That's awesome.
I'm fine with 9.
All right.
That's going to be both Monday and Wednesday?
Yeah, we're just going to go like that.
Sounds
Monday
great.
and Wednesday. Since we're running kind of hybrid, you know, it's not like really a reduction in class hours because there's videos for you to watch at home as well. So, you know, it's not really a problem shaving a half hour off. And it makes it easier for people to get here.
Will we still get out at the same time? Because I am also a student worker and I have to go to the administration building after class.
Yeah, same. Oh, we getting out at the same time? Yes.
Okay.
Yeah, usually we're going to finish by 11. And those of you that are in lab, we start at 11:30. But 11 seems to be, I've lost most of you by 10:45 anyway. Like you've all checked out. So I usually end up stopping around 11. And then lab's like a completely different class. For those of you that are in, are you guys in lab?
Yeah.
Right. For those of you that are in lab, when we end class today, you guys stick around. If you're in lab, stick around after class.
Nope, I am not in lab. Thank you, guys.
I'll go over the lab right after class, and then you guys can just go for the day. So for today, I'll go over the syllabus in the lab and show you how to get into the stuff we're doing. And then you don't have to wait around until 11:30. You don't have to wait until, what time's lab? 8:30? Yeah. You don't have to wait around until 11:30. We're just going to do it in here, and then you guys go. So All right. Any questions so far?
Let's start.
Really?
Yep.
You're so excited to start.
Not really, but I just want to start.
No questions on like the syllabus?
Nope.
Not going to get you out any sooner. All right. Yeah, so let's start talking about chemistry. I'm really becoming like, she doesn't even wearing your mask anyway. Why am I wearing it? We're supposed to wear it, you know, I think. I've gotten like, you know, the first year I was all in. I'm like, okay, I'll do it. I'll wear it. Second year, I was still into it. But the last like 4 or 5 months, I've been, I don't know. It's not comfortable. Been like a baby about it. Didn't want to wear it. It's against my like freedom and stuff. All right, so I feel like I can't. I don't mind actually wearing it. I feel like when I'm teaching, like the volume of my voice goes up. I feel like I have to compensate or something, and it's just a paper mask. I don't like understand what it is that I can't just speak, and I feel like my words are coming out even more confusing and.
I feel the exact same way, and I also feel like I can't hear when I have a mask on or whatever reason.
It messes with your hearing.
I really believe it does.
Yeah, I don't.
Pretty sure we're at a good distance, so I think you're okay.
Yeah, I'm okay. I'm protected from you guys. It's really all that matters, isn't it? Chemistry is, yeah, it's like the foundation of biology. You really need to understand a little bit of chemistry. We don't go hard on it. There's really only 4 different atoms or elements that we're going to discuss in class that you're responsible for, and they are these: carbon, oxygen. I don't know why I put you. Nitrogen, and what am I missing? Oh. Those 4. Those are the 4 that we really deal with.
Push the screen over a little bit.
How you doing? You're okay?
Mr. Klaus,
Yeah.
push the screen over just a little bit. There we go.
So those are the 4 we're going to deal with in biology, because most things that are living or that used to be living are made up of these 4 atoms. Right. So this is about 95, 96% of the atoms in your body are these atoms. This is about 96% of you. Your food. This is about 96% of the food that you eat. It's these 4 atoms. Anything that used to be living, so like oil products, you know, that used to be whatever it was, dinosaurs or something. They used to be living. So that's, you know, oil's made up of this type of stuff too. Mostly these 2, but think about like water. Water is made up of those 2, and the air is mostly that, and then some of these. And so, you know, these are the 4 atoms we're going to deal with. So I guess first we have to talk about what is an atom. And I don't have the textbook definition, but an atom is something that you cannot break it down any smaller, right? So it's the smallest thing that you can get to, and if you were to make it any smaller, it would no longer be that thing. So if I take a piece of carbon, like a diamond, I take a diamond and I keep making it smaller, 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 because all a diamond is like carbon. At some point, I'm going to make it so small that it's no longer carbon, right? So that place is like the atom. And all an atom is, it's got like 3 parts to it. It's got like this. I'm gonna make that a little bit bigger. An atom is like this nucleus, like a planet. I think of it like a planet, and then I think of like a moon orbiting around it. This thing right here is just like an orbit, right? And there's my moon. So it's just like a moon going around a planet, right? And inside the planet, or we call it the nucleus, you have these things called protons and neutrons. And then the moon, the thing orbiting around it is an electron. So you got 3 parts to the atom. And they have charges. So the electrons are usually negatively charged, and the protons are usually positively charged. And neutron is neutral, no charge. So that's like a simple basic atom. Proton, neutron, electron. I might be saying a couple of things today that if you like chemistry, and if I might not be telling you exactly the right information. Like, for example, I'm going to tell you that this is an atom of hydrogen, right? Technically, hydrogen doesn't have neutrons, right? But I'm just follow along with me. I'm just trying to get you from point A to point B. So this is like the most basic atom. It's got a proton in it, it's got a neutron, it's got an electron. This is negative going around it. This is positive in the middle. The positive and the negative are kind of balancing, canceling each other out. And this is like your simplest atom, right? So this would be like hydrogen. So when you look at like that periodic table back there, for those of you that can see it, if you go to the upper left, all the way upper left, and you see that red H, right? That just means that's hydrogen, H for hydrogen. And then you'll see up in the corner, there's like a number 1, like a blue 1. And if you follow all those atoms, whatever they are, it just goes like 1, 2, 3, 4, 5, 6, 7. It just keeps going down, right? And then when you get to the bottom, it says like 103 or something. But all those atoms, like all the way in the upper left, it says, it's got like that little box. It says like H1. And if you look all the way to the upper right, that one says helium, He for helium, and it's got a 2 up there. Don't worry about it if you can't see it. But that's all all that's happening is that you see like that 1. All that's telling you is that means it's 1 proton. So it's like H for hydrogen, and then there's a 1, meaning that there's 1 proton. The proton is how we define what an atom is. Like, how do I know that this is hydrogen and not gold or mercury or something? Because it has 1 proton in it, and that's it. That's all it's got. I don't actually care about how many neutrons are in it. As long as it's got 1 proton it's hydrogen. That's it. Even if there's no electrons or 100 electrons, 1 proton. That's how we define what an atom is. Right, and so that's why you see like the H, and then it's got like a blue number 1 up there in the corner. That's telling you, that's called the atomic, that's the atomic number.
Wait, so what's the atomic number?
The atomic number is the number of protons in an atom. Because that's all that, when I'm saying this is hydrogen, that's the only reason that I'm saying that, because it's got 1 proton. Of course, if there's 1 proton, I'm going to guess that there's also a neutron, and I'm going to guess that there's also 1 electron. Not always, but usually, just assume it. If there's 1 proton, that means that there's going to be 1 neutron and 1 electron also. But the proton is what makes it hydrogen. That's the atomic number. And so there are 4 atoms that we care about, right? That we're talking about, right? And I already wrote it, but I'm going to write it again. What was it again? I mean, there's hydrogen. What were the other ones? Nitrogen, oxygen, and carbon. There was 4 atoms, and I just wrote the letters. Hydrogen, carbon, nitrogen, oxygen. Those 4 atoms are the 4 that we care about in biology. What's the atomic number of hydrogen? Meaning how many protons are in it? Just 1. Carbon is going to be 6. Nitrogen is going to be 7. Oxygen is going to be 8. That's the atomic numbers. You have to know that. So there's 1 proton in hydrogen. There's 6 protons in carbon. There's 8 protons in oxygen. And if you look up there and you just kind of follow, those of you that can see the periodic table, if you kind of followed it along, you'd see that when you get to number 6, it's going to say C, carbon. This here is just, right now, we just put 1. But I'm going to write these also. That's kind of what I'm going to build towards. I'm going to start making this atom more complicated. This is all in that video, by the way. Okay, so now what I'm going to do is I'm going to make this an atom of helium. Again, you don't have to know that. It's not one of the 4 that we need to care about. I'm just writing it. So helium has atomic number of 2. So that means 2 protons. I'm just going to write P for proton. 2 protons. I'm going to assume, because it has 2 protons, it also has 2 neutrons. So I just put 2 protons, 2 neutrons, and also 2 electrons. There's 1 electron, and I'm going to put the other here. They're orbiting, so it doesn't matter where you really put them. I mean, in chemistry class, they're going to tell you where to, like, you know, there's a way to do it, but we don't care. They're just orbiting. There's 2 protons, 2 neutrons, 2 electrons. That's helium. But you don't have to know helium. That's not one of the 4, right? But I'm just going up in number. Sometimes in your book, you might see it written as maybe like this. They might write it like this. it doesn't matter what it is. You just know that whatever it is, you know, I'll even put like an X here. It's an electron. There's 2 electrons going around. Right, but I usually just write them like that. So there's a planet, and inside the planet, 2 protons, 2 neutrons. The 2 moons are orbiting around the planet. Those are my 2 electrons. And it's just going to keep going like this. I can add now. I'll go 3 protons. That's lithium. Again, don't need to know it, but I'm just saying. 3 neutrons. And now I'm going to put 3 electrons. I got to put a 3rd electron on here. Here's the problem. This right here only holds 2 electrons. This orbit right here. So I got to make an orbit like a little bit further out because this one only holds 2 electrons. That's all it can hold. So if I want to make the 3rd electron, I got to like go out a little bit more. And I'll just write it up there. And I'm just going to keep adding. That's all I'm doing. Just trying to give you like the basic idea. Right, we could jump all the way to carbon now. What's the atomic number of carbon?
6.
6. What does that mean? Atomic number of carbon 6. What does that mean?
6 protons.
6 protons. So as soon as I see this 6 protons, I know it's carbon. This is already carbon because I put 6 protons in it. Or I see 6 protons. I'm going to assume that there's also 6 neutrons. And then I'm also going to assume that there's 6 electrons. Here's 2. I can put up to 8 of them here. So I got 1, 2, 3, 4, put 1 here, put 1 there, 6. 6 protons, 6 neutrons, 6 electrons. We're going to take a break in about 5 minutes.
So the second orbit can hold up to 8, right?
The second can hold up to 8. This one only holds 2. This one can hold 8. So I've still got room. Why am I putting these electrons at the places that I put them? No reason. You'll put them anywhere you want. They're orbiting. So all of these 6 electrons are going around. Your book might talk about like p orbits and s orbits. Just ignore it. We're just going simple. It just goes around. So that would be carbon. And of course, if I wanted to make it nitrogen, I just put 7 in here. And then I got to put another electron out here. So I'll put it there. That would be nitrogen. And then the last one you had to know was oxygen, which was 8. So I'll just say, all right, there's 8 protons, 8 neutrons, 8 electrons. Where I put the electrons, it didn't matter, but only 2 can go here. The other 6 I had to put on the second orbit. We call these things an orbit, or we can call it a shell. I'll call them either. Sometimes I call them an orbit, sometimes I call them a shell. And then it just keeps going. Actually, I'm going to do one more that you don't have to know, but I wanted to show you something. I'm going to do sodium. Sodium has an atomic number of 11. So 11 protons. Again, you don't have to know this one because this is not one of the 4, but 11 protons, 11 neutrons, 11 electrons. So you see where I'm going to fill up the shell. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have room. Right? This only holds 8. So it's filled. So I got to go one more out. So the first one holds 2. The second one holds 8. I got to make a third one here that's going to hold 8 also, for purposes of this class. And then I'll put it up there. So there it is. That's about as complex as we're going to go. We're not going to go past 3 orbits.
Do you want us to know this one?
No,
Okay.
just the 4 that we wrote. But I'm just showing you that there's a third shell. Like sometimes, you fill this shell up or this orbit, it only holds 8. Once you fill it, you got to go out to make the next one. Although we're not really going to be doing that, but there's a point that I want to get to after our break, and it kind of involves this. So that's kind of why I wrote it. But that's, we don't go further. It goes more, right? It keeps going. It goes, I don't know, 118. So there's atoms with 118 electrons. I don't know what they look like, right? It keeps, that's chemistry. That's for another class, right? We're just keeping it like as simple as we can. So that's about it. Let's take a break. We'll meet back here at 10, and we'll meet back here at 10. I'll probably go for about another 40 minutes maximum, and then we're done for today. That sound all right?
Plus the lab after.
And those of you that are in lab, you're going to stick around right after.
Okay.
But everyone else can leave at that time. All right, so let's take a break. I'll see you guys at 10.
Okay.
I'm going to close my laptop, and I'll come back in at 10.
Okay.
All right. right. Wow, I'm back. I have a question for you. No, I don't know. It's too soon to ask. What charge do these things have? Okay. They're negative. They're electrons. They're negative. A lot of people get confused and say that they're positive, but these things are all negative. That's positive. P for positive. Proton, positive. Neutron, neutral, no charge. Positive, nothing. Negative. I've got 11 positives. I've got 11 negatives. The negatives and the positives are kind of like canceling each other out. So yeah. I'm going to redraw this a lot smaller. I want to show you something else. In fact, I'm going to draw the largest atom that I'm going to draw in the class. Okay. This one's called, this is going to be chlorine. Again, you're not responsible for knowing that because it's not one of the four. I'm just drawing it to show you something else. So here's my nucleus. And inside the nucleus, the atomic number of chlorine, and I'm just going to write Cl here. That stands for chlorine. The atomic number of chlorine is 17. That means that inside here, what does that mean? What's inside there? I got 17 protons. And what charge do those have? Positive. They're positively charged. I've got 17 neutrons. They don't have any charge. And then I got to put 17 electrons on here. How many electrons can I put on this first orbit?
Do we have to know this
shell? No, I'm just, what you do have to know is how many electrons need to be here. But you don't have to know the atom.
Okay.
2.
Only 2, that's all that it holds. So I'm just going to put one there and put one here. How many on this second one?
8.
Yeah.
The success she's seeing with her single hours and hours.
Well, how many do I have like so far?
10.
After I, yeah, I'll have 10 when I get to it. How many more do I need?
7.
Yeah. So do I have enough room here to do 7?
Yes.
Yeah. I don't know why I'm drawing them like this, but all right. So there's 7. We could fit one more, but there's only 7 here. It holds up to 8, but we have 7. I'm going to draw another atom here. I'm going to put the sodium back here. So sodium was atomic number of, well, let me draw my thing. And these little dashes just mean orbits.
1, 2, 3, 4, 5, 6, 7.
So here's my, I'm going to put Na for sodium. Na stands for sodium. And you don't have to, again, you don't have to know that. I'm just putting it. I've got 11 protons, 11 neutrons, and I got to put 11 electrons around it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, and then there's my last one, 11. So I got 2 atoms. They're kind of hanging out next to each other. I've got sodium here not the best drawn, but sodium's here, chlorine's here. This holds 2. This can hold up to 8, and it is holding 8. This can hold up to 8. So here's the thing about atoms. Atoms, they like the outside. They only care about the outside. They only care about external appearances. You know what I'm saying? They only care about what is on the outside. Atoms, when they look at each other, they don't care about this. They don't care about that. They don't care about that. They only care about this outer shell. Whatever the most outside external thing is, that's what they're using to like judge each other and interact with each other. So if you think of it that way, if you look at chlorine, this outer shell can hold up to 8. It's got 7 electrons on it. So that's kind of like, that's sort of impressive. But if you look at sodium, it's only got 1 electron. So they're always judging each other, and they're always looking at the outer shell. They're never looking at like what's on the inside. So chlorine's like judging sodium right now because it's only got 1 electron. Chlorine's got like 7 electrons. They're always trying to get as much as they can. If I can fit 8 here, I want 8. But chlorine only has 7, but it wishes it had 8. You know, whatever they have, they wish they had more. Sodium, it has 7 more here. It's never going to happen. Chlorine wishes it had like 1 more, just to be full, to be like complete. So in this particular case with these 2 atoms, probably some of you know where I'm going. What's going to happen is that chlorine is going to steal this electron just because it can, right? And so you don't have to know, you do not need to know like when this happens. You don't even need to know like why it happens. I just want you to know like what's the result. What's going to happen to chlorine after it steals it, right? So I'm going to give it over to, I'm going to take it now. So chlorine's going to take it. I'll put it in black. There it is, the stolen electron. Chlorine stole this electron. In fact, this orbit is gone now. So chlorine took the electron from sodium. Why? Because you'll learn in the future that some atoms are thieves. They steal electrons. And some atoms are punks. They're enablers, and they allow their electrons to be stolen. And sodium is one of those. And so this throws off the balance. It's no longer balanced, right? You have 11 positive inside, but you only have 10 negatives going around it. So they're not canceling each other out anymore. So you've got 11 positive charged protons. Neutrons don't have any charge, so we don't care. 11 positive, but we only have 10 electrons. It's thrown off now. This whole thing is positively charged. So sodium's always positive. Again, you'll just learn that. I don't care if you know that now. I just want you to know what happens when you get your electrons stolen by someone. You become positive. Doesn't sound positive, huh? That sounds negative. So you got to remember that. It's not. Like getting your electrons stolen is a positive thing. It's like the opposite of what we think. So this whole atom here is positive. And then chlorine, stealing is not a positive thing. Stealing's negative. Chlorine stole the electron, so it's got 17 positive charges here. But once it stole this, now it's got 18 negatives. So that whole thing's negative. Chlorine is always going to be negative because chlorine steals electrons from other atoms. Sodium is always positive. It allows it. So some atoms you'll learn in the future, you'll learn whether they're positive or negative. Like all the minerals, these are minerals that are in your body. This is salt. That's what this is, table salt. Right? You'll learn in the future that electrolytes, minerals in your body, they always have a charge. They're never without a charge. So potassium, it's positive. Magnesium, calcium, they're positive. Iodine, negative. Phosphorus, negative. You'll just kind of learn them. You don't need to know them this class. You'll learn them as you go through. You'll just associate a charge with a particular mineral. So if you look at like a food label, you'll see two minerals that is always on a food label, calcium and sodium. They're both, when I think of calcium or sodium, I think positive. They're both positive charged. They're both atoms that get electrons taken from them by other things. So, but for now, again, you don't need to know which ones are which. For this class, you don't need to know. You don't need to know why this was stolen. Well, why is it? What is it about chlorine and sodium? When are the scenarios where this is going to happen? You don't need to know. You just need to know what is the result, and that's the result. It's positive because it lost an electron. It's negative because it gained an electron. So there's some times where it's not all balanced out. You don't have an equal proton, neutron, electrons. They're not all equal. Sometimes there's differences. When? You don't need to worry about when. Like, how will I know that it's, by the way, we call this an ion. These are called ions. Well, how are you supposed to know what atom is an ion and what atom is not an ion? You'll always see a plus sign by it. So you don't have to think about if it's got a plus or a negative, it's an ion. Otherwise, it's not. The four atoms that we deal with, only hydrogen. Hydrogen is someone that gets its electrons stolen all the time. So that's the only one that you'll see. But sometimes hydrogen's not like that. But if it is, you'll see it. It'll have a plus by it. So you don't have to.
You said it's electrons stolen?
Yeah. If its electron is stolen, it's positive. If it steals an electron, it's negative. In fact, there's particular words for this. If it's an ion, means it's charged. It has a charge. Like carbon usually doesn't have any charge. Right? But if it's charged, if an atom has a charge to it, it's an ion. But there's particular names. If it's positively charged, we call it a cation. C-A-T-I-O-N. The T looks like a positive because this one over here is called an anion. If it's negatively charged, we call it anion. So like chlorine, in this case, chlorine is an anion. It's negative. You only need to know why it's negative. It's negative because it's stolen electron. That's it. That's all you need to know. Sodium is a cation. Why? Because it lost. The real terms is losing or gaining. It lost an electron. It gained an electron. Right?
Wait, so Wait,
Yeah.
wait. So go back. You said it's negative because it's stolen an electron. So what's negative because it's stolen an electron? Like what?
This atom, it's
Chlorine? I mean,
we call this an anion.
wait. So isn't that chlorine?
Yeah,
Okay.
chlorine. This chlorine happens to be an anion. And why is it an anion? Because it gained an electron or stole an electron. I'm using the word steal, but it's gain. It took an electron from another atom. Why is this one a cation? Which means positive charge. Cation just means positive. Why? Because it lost an electron.
And anion is negative, right?
Yes. You don't need to know for now, like what atom took it. You'll kind of know in the future. Like this is a very typical scenario. Like these two work together all the time. Like they're together all the time, and they're stealing from each other. And like I mean, the chlorine steals. Like you'll just know it. Like I said, this is table salt. Like these two are actually going to stick together now. You know, like here's the positive and here's the negative. It's like a magnet, right? These two are going to come together, and that's going to make like table salt, sodium chloride. But they're sticking together. What's bringing them together is that it's positives and negatives tend to stick together. But yeah. So, do you have a question? Any questions about that? I know that I kind of threw a lot at you, but I've got a video that's just about this, and I use the same atoms. Again, just to recap, all I want you to know is, all right, I see this thing, and there's a positive sign here. Why did that happen? And the answer is some other atom took its electron. Which one? You don't care. Doesn't matter. Just something, some atom took its electron. You see this? I don't even know what Cl stands for. Yeah, I know it's chlorine, but like you don't even have to know. Just why is it negative? Because it gained an electron. Doesn't matter where it got it. You don't care. It got one, and so it's negative. And this thing is going to stick to something that's positive. And this thing's going to stick to something that's negative. These two are going to bond together. It's really drama. They're just these atoms are all into drama because they're constantly stealing from each other, and then like this one's like an enabler, and chlorine's like, hey, I know I stole this from you, but you want to hook up anyway, Netflix, whatever. Sodium's like an enabler. Sodium's like, yeah, okay, fine, let's get together. And then later on, chlorine's going to be like, I had a great time, but chlorine's going to take off and go hook up with someone else, and then sodium is going to wait around, and someone else will hook up with it, and then they're going to form like these love triangles, and there's like, I know, trying to make it sound interesting, but it's really not. But and then the whole thing about them being superficial, right? They only care that they have like frosted tips, and they don't care about like what's inside. They just care about what's on the outside. And by the way, the outside. This is the outside, right? This is like the most outer part of the atom. Call whatever is the most outer, this outer shell. And you guys can't see it. I'm gonna move the thing. Valence. So these are both valence shells. Whatever the most outer shell. Because that's all that atoms care about. You're just looking at the outer shell. Oh yeah, you guys can see it. So this is only 2 orbits, right? 2 shells, 2 orbits, but this is the most outer one. Whatever the most outer one is, we call it valence.
I'm kind of lost. What did you just say?
Like whatever the most outside part of the atom is, the most outer shell, we call it valence.
So the most outer shell is like the valence.
So if you look at this one, there's like 3 shells, right? 3 orbits. But this outer one's the only one that matters. This one only has 2. It doesn't matter how many there are. Whatever the most outer one is, that's what we care about. That's how atoms interact with each other. They're looking at the outer shell and they're making decisions. Am I going to have a relationship with that other atom? What kind of relationship is it going to be? Is it going to be based on theft and enabling, or is it going to be based on like mutual sharing? Right? Because sometimes these atoms, they won't steal from each other. What they'll do is they'll share electrons with each other instead. That's like a nicer way to go. Share with each other, and that kind of keeps you together. But this one, no. This one's like based on theft. And they decided to get together anyway. What do you think? I give you a lot so far. I probably have like one more thing that I'm going to tell you about. So that is actually, we're looking at a few things here. One thing is that, I'm going to erase the word valence for no reason. One thing is that we learned about what an ion is, like the case where everything's not equal. The protons and the neutrons and the electrons, they're not all the same. There's fewer electrons in this case. Or here, there's more electrons. They're not equal. Right? So whenever that happens, that's an ion. They're both ions. But then I told you about these 2 words. Cation means positive. Anion means negative charged. Right? The whole atom is negative. The whole feng shui thing's thrown off here. You've got more electrons than protons. You've got fewer electrons than protons. It happens sometimes. You don't need to know when it happens. You just need to know what's the result, right? The result is something's going to be negative, something's going to be positive. This is the secret to how things work in your body. If sodium is not positive, this sodium right here, this atom, even though it's like I was calling it a punk and an enabler that allows itself to get stuff stolen, it's responsible for your heartbeat. It's responsible for all your nerves firing. It's responsible for moving water around your body. It's got very important jobs. If it wasn't charged, it wouldn't do these jobs. Think about like electrical currents in your body. Like, your heart's got like electrical, you see that EKG and the paddles and clear and all that crap. That's so electrical, right? There's electricity in your body. This is making the electricity. This is one of them. There's other ones too, like potassium and calcium. They work together to make the electricity that flows through your body, like in your nerves, all your nerves firing, your heart beating. So this is important, like down the road. I'm not just giving you chemistry and then, okay, chemistry's done, you're never going to see it again. No, this is biology. Like when you get into anatomy, this is anatomy. This is like second semester anatomy. All right, so it means something. This chlorine here is going to go on to your stomach, and it's going to make the stomach juice. This chlorine is going to break away from the sodium. Like once you eat salt, the chlorine's going to break away. It's it's going to be like, I got other places to go. The sodium's like, fine, I got other places to go too. I never needed you. And then chlorine's like, okay, well then you don't mind if I take the electron with me. Sodium's like, fine, I don't care. And it goes to the heart. This is going to go to the stomach, and it's going to hook up with hydrogen. It's going to make acid, all the acid that's in your stomach, right? So I'm trying to tell you is like, this is like building to something else. Like it means something within biology. It's not, I'm not just doing chemistry because that's chapter 2 in your book, or just because, right? Like you have to, when you understand this stuff, the other stuff's easier. You just get an idea about like how these atoms react, and it's all going to mean something in like the physiology of your body or any living thing. You have like, I'll give you another example. There's about 10% of people, you have this gland like right here called your thyroid gland, and it regulates your metabolism. It makes like hormones that make your metabolism high or low, right? You don't want it to be low, because then you never can wake up. You're gonna be putting on a bunch of weight, just low metabolism. And you don't want it to be too high either, right? But really what happens to people is they usually have like this gland's not working, about 10% of us, and you don't make enough hormone. So your metabolism's like too low, right? What this gland uses to make metabolism is iodine. So iodine, we just put like an I for iodine. And you get iodine from like shrimp and like seafood and stuff like that. Your gland, your thyroid gland in your neck, it uses the iodine, and iodine's negative. So again, this is like another mineral. When I think of iodine, I automatically associate that with it. We use that to make the hormone for our metabolism. So if you don't have enough iodine, you can't make the hormone. But sometimes, your thyroid gland just stops working in general, right? You got to take medicine. You got to take like synthetic thyroid medication.
Synthroid.
Synthroid, levothyroid.
I'm on it.
Synthroid. Yeah, like some of you are taking it, right? It's not uncommon.
Right now.
Yeah. See, I already got 2 people at least taking it. That pill that you take, Synthroid, is negatively charged. So you shouldn't be eating food right after you take it or right before, right? Because your food's going to have positively charged things in it. So if you eat food and you take the Synthroid, the negative pill is going to start binding with the positive things in your food, like sodium. And you're not going to be able to get that into your blood. You just bind it up and it becomes food,
I often wondered why I have to wait 30 minutes before I can eat or drink anything, including water. And I've wondered that for years.
Yeah, you have to wait 30 minutes.
Because let's say you drink milk. Like, what's milk? Calcium.
You have to wait 30 minutes.
Calcium's positively charged. That's going to bind to the iodine in your pill. So, yeah, that's why you got to wait. Yeah.
I've already learned something in class.
And sometimes in hospitals, like if let's say you had to get an operation and you're in like the hospital bed and you're kind of like out, right? You're in the ICU, you're out. Like you can't tell people, hey, time to give me Synthroid. They will come give it to you, but they're not going to give you the pills, right? They're going to give it to you in your IV. So all the pills that you take on a day-to-day basis, they make IVs out of it. Sometimes, but you can't give the IV for the Synthroid and then give an IV for food. And sometimes that happens. And then what's going to happen is that like the patient's going to get worse because their metabolism's going down, but you don't know why. It's just something as simple as you gave the food at the same time, like as a nurse, you gave the food at the same time that you gave the Synthroid. But you don't know that that's what's making the patient worse. You're like, shit, what happened during the operation? Like what? You start looking at all these other things, and it's just something stupid that you didn't time it out as a nurse because, you're lazy. not you. People are lazy, and, you know, it's like, that's what I'm saying. Like these things, cation, anion, they're gonna matter. It's like stuff that's gonna come back in your future. And people tend to say, like, well, I don't need all. I mean, this is partly true. I don't need all this stuff. I'm gonna learn what I'm gonna learn when I do it. That's partly true, but it's also partly false. And you never realize it because by the time you're a nurse, you know stuff. If you're gonna, you know, when you pass your nursing license, whatever, you're not like just some dude off the street. Like you know some more stuff. You just don't realize you know it because you've been doing it. So you think that you're learning everything once you start working. That's not necessarily true. There's like background information that you already have. You just don't. You forget it because you know it. When you know something, you don't. Like for me, I think I'm talking like ABC, right? But for some of you, it's not ABC. That's only because like I just do it all the time and I don't realize that I know it. I don't know if that makes sense, but all the stuff in this class, biology, is used later on. Now, if you're like a psychology major, take the class, get your grade, dump it from your head. You should. You'll never need it again. It'd be nice to know, you know, if you're a psychology major, you have to know how like neurons work and stuff. It's not like you're never gonna, you know, but if your major is anything having to do, like I'm doing radiology, I'm gonna be a dental hygienist. This is all coming back to you. You know, so it's just try to like, you know, put it in your permanent memory. Try to learn. I mean, you got to take the tests and stuff anyway. Might as well just learn it permanently. It'll make your life easier. Yeah, if you're a business major, yeah, you're right.
What if you're a teaching major?
Yeah, you're gonna have to teach science, maybe.
No, I'm not.
Yeah,
I'm an English teacher.
you think that until you start doing it, and then they're like, "Look, we need you here today."
Nope.
You never know. You think I started off as? You think my bachelor's degree is in biology?
I will hope so.
It's not. It's in sociology.
Oh, heavens.
When I took this class, I was like, I'm never going to need this again. And I took it. I dropped it twice, and then I took it my last semester. I'm like, you just got to do it. You got to do it, or don't graduate. You know, but you never know. That's the point. You never know what you're going to end up doing. You think you're going to teach English, you probably will, but you never know. They might, at the beginning, because you're new, they might keep pulling you into the science classroom to sub because they don't have people. Obviously, you're not a science teacher, but that never stops people in education, especially in like K through 12. That never stops anyone. You're going to be subbing in science classes, and you might be like, oh, this is okay. I guess I could do this, but yeah. All right. Where are we with time? 10:39. All right. Last thing. Let me show you the last thing here. So, ions. I'm gonna erase this whole thing. I'm gonna reset. I'm gonna draw a new atom. This was talking about when the protons and the electrons don't match up. Right? You have more electrons or you have fewer electrons. I'm going to draw an atom of carbon. And I'm just going to put C because I'm being a little bit lazy now. But you know what's inside of here because you're thinking, what's the atomic number for carbon? And what would you say? What do you guys think online? 6? So 6, that means what? What's inside of here?
6 protons, 6 neutrons, and you have 6 electrons.
Yes, 6 protons. Well, actually, you know what? I actually need to write it here. I forgot. So yeah, there's 6 protons, 6 neutrons, and then there's 6 electrons. And I can put 2 here. And then how many do I have to put here? How many could I put? I mean, how many could it hold?
8.
It could hold 8, but we're only at 4. All right. What I'm going to do now is I'm going to change the neutrons. Instead of 6, I'll just put 7. That's it. What does it do to the charge of this atom? Does it make it negative or positive?
No,
No. Because what charge do neutrons have?
it's neutral.
Charge. So it doesn't matter. I could put 100 in here. Is it still, I'm kind of pointing as like a clue, is it still carbon?
Yes.
As long as the protons are 6, nothing else matters. So it's still carbon. It's not any different charge. It's just got more neutrons. What does that mean? Well, right now, nothing. But we call this an isotope. An isotope is when you have like more neutrons than protons. It's a little more crowded in here. That's kind of all that's happened at this point. Starting to get a little crowded. At some point, it's going to get too crowded. What that point is, it's different with every atom, right? I know carbon, but I don't know anything else. Like I don't know when it becomes too crowded, but about 8 or 9, it gets a little bit too crowded, and this thing's going to break open. It's too full. It's going to bust open, and all this stuff's going to just leak out. And when that happens, we call it radioactive. At what point is it radioactive? Who knows? You don't need to know. Not unless you're going to go into like nuclear medicine or something. You don't need to care. But at some point, when you put too many neutrons in there, it's gonna
Wait, so this the whole radioactive business. Say that again.
At some point when you put too many neutrons in here, it becomes like too crowded, and this nucleus is going to break open, and it's going to leak everything out. So why does that even matter? Well, you can use it. Like sometimes they'll give you something called like a barium swallow. Oh no, let's use the one for iodine. Okay, for the thyroid, let's go back to that. Your thyroid uses iodine. All of the iodine in the world is regular, normal iodine. Some of them are isotopes, like radioactive. Some of them have extra neutrons, like a fraction of a percent. I could take those radioactive iodine and I can inject it into you. It's not going to kill you. I'm going to inject it into you. All those radioactive iodine is going to go up into your thyroid gland. It doesn't go anywhere else. Only your thyroid gland uses the iodine. So it's not like it's going to go to your liver or something. It's all going to come here. And so now you got a bunch of radioactive iodines up here, and then you could take like that X-ray and get like a 3D map of your thyroid gland. And you could see like, do you have any tumors? Is anything missing? Like what's up with your, or again, you could do it like they give you a barium swallow. They give you this radioactive isotope, and you swallow it, and it coats your esophagus and your stomach. And then again, you could take that X-ray thing, I don't know what it's called, and I get like a 3D shot of your stomach. Do you have any holes in your stomach, like an ulcer? Do you have any holes in your esophagus? Is your esophagus sticking up through your diaphragm? Like what's up with the whole thing? I can get like a 3D map of your like GI tract and see like what's going on with it, right? But they give you like a radioactive swallow. So those are isotopes. So usually most atoms are regular atoms, meaning that like 6 protons, 6 neutrons, 6 electrons, but some of them, a few of them are isotopes. Like carbon, for example, most of the carbon in the planet are just regular, but there's like a fraction of a percent of them are isotopes. So I'm just showing you a case, an example of when these don't match up. So an isotope is something where you have, you're probably thinking like, well, what am I going to ask you about? An isotope is something that has more neutrons than protons. How many more? Who cares? Not important. Just there's more. And sometimes you'll see it. And so I'm going to write this in a different. I'm going to write this in a way like sometimes how they write it in chemistry. So you'll see it written like C for carbon, and then you'll have 2 numbers next to it. One of them is going to be, I don't know where they are. Take this one. No, wait, I'm going to put it on top. 6, that's the atomic number. So carbon, the 6 means the atomic number. Well, we can weigh, these things have a weight. These things weigh something. And how do we come up with the weight? We're not going to count these because they're too light. Right, we're just going to count these. We just add them up. So 12. The weight of this atom, 12. So I just put, you'll see 2 numbers with it. You'll see like a 6, and then you'll see a number that's somewhere about twice as much. So that's sometimes how you'll see it written. This is the atomic number. That's the weight. So we call those Daltons. So this is 12. This thing weighs 12 Daltons. All I do is I just add up the protons and the neutrons. If you take chemistry, it's actually a much more complicated. Like they figured it out, something like 1.7 times 10 to the negative 23rd grams, right? And then I'd have to do that times 12. I don't know how to do 1.7 times 10 to the, I don't remember how to do all that. Luckily, someone said, hey, why don't we just call a proton a Dalton and a neutron is a Dalton? And we just add these up, 12 Daltons. For biology, that works so much better. But what if you see this? That means that the weight is 13, not 12. Well, you know the protons aren't changed. You can't change a proton. If you change the protons, it's not going to be carbon. And it's still carbon. So I didn't add a proton in here. That's not possible. So it has to be the neutron. So when the number is more than double, that's why. Because this is an isotope. I know because it's more than double the number. This is what we do in biology. In chemistry, they do it different, and I don't even know what that says up there. Wait, I'm going to look for a second. 12.0108. The real number here is like this. So it should be written like technically, if you were taking a chemistry class, it'd be written like this. Atomic number, the atomic weight. It's like a little bit more than double, right? It's like weird. Like why don't they just make it 12? We do in biology. What they're trying to say is that like most of the carbons in the universe are normal. But some of them, a few of them, not the universe, the planet, a few of them are like isotopes. That's why you get a little bit more than 12. But we don't deal with this in biology. just go with that. But if you look at the periodic table, you'll see it's not exactly that. You got to round it up or round it down, right? So it's the atomic the atomic weight is very easy to do, right? So if I go oxygen, atomic number 8, atomic weight, 8 times 2.
16.
Yeah, that's all you do. It's not exactly 16, but we just round it, right? So we call this the atomic mass or the atomic weight, right? Takeaways from today. Let me erase everything. What you should know before you come in Monday, what should be in your head, what's an atom? You should know what an atom is, and what are the 3? I think they call it subatomic particles. What are the 3 parts of an atom? Well, you already know that: protons, and then neutrons, electrons. You got to know the charge, right? So you got to know that electrons are negative. Electrons are not positive. That's one thing you got to know. Oh, and then how many electrons are on each shell or orbit? How many electrons? So the first one, 2. The second one,
8.
up to 8, and the third one up to 8. And that's as far as we go. You'll learn in chemistry, there's cases where that's different. Like sometimes one could hold up to 18 or whatever. That's not. We're not trying to make it more complex. So 2, 8, 8. And then the most outer shell we call a valence shell, or orbit, valence orbit, or valence shell. Whatever the most outer one is, right? This is hydrogen. That's the valence shell for hydrogen. It's only got 1, but that's the outer one. So that's the first thing. I'm going to erase this now. The second thing, what is an atomic number? We'll also do what is an atomic mass. Atomic number is the number of protons. To get the mass, what do we add together?
Protons and neutrons.
Protons and neutrons. That's it. Add the protons and the neutrons and you get the mass.
Wait, say that one more time.
The atomic number is just the number of protons. That's all it means. That's how we define an atom. That's how we tell the difference between carbon and nitrogen. It's by the atomic mass.
So atomic number is about how many protons?
Atomic number of protons. Atomic mass is the weight of the atom, how much it weighs. We just add the protons and the neutrons. That's how we get the weight.
And protons and electrons, right?
We don't do the electrons when we do the weight. We just do the.
I'm talking about the mass.
Yeah.
So
mass. Protons, neutrons only. They think that an electron weighs like 1/1000th of the weight of a proton. So they don't count it. To me, it all weighs nothing. I don't know how. This is like all theoretical. What's an ion? Why did it become an ion? The two types of ions. Cation, anion. We did a lot of stuff today. I think I should stop it there. I went over. I'll probably go over some of this stuff again on Monday. Just so it sticks in your head. I think the videos, you know, I don't have this on the video, and I don't have isotopes on the videos, but that's fine. It's in a different video. All right, so I'm going to post this. I'm going to stop recording. I'll post this sometime today. Those of you that are in lab,